Hi there. Welcome to this session, Origin of Lean Six Sigma. We're going to be talking about that aspect and also what other terms are normally used in Lean Six Sigma. Thank you for joining us today. This session will be recorded on our social media. Let's go ahead. I'm going to go ahead and share my screen. So this is just one piece of the Lean Six Sigma approach. We're going to be talking just about a few items, and this is a comprehensive class that could be from the lowest level to the highest level. We'll see. So let's ask the first question. Why do we need Lean Six Sigma? As you can see over here on my screen, one of the elements will be cost saving. Another will be cost reduction, quality assurance, process improvement, customer experience. At the end, we are talking about looking or chasing excellence. That's what it is all about when we talk about Lean Six Sigma. Now, keep in mind that typically most organizations that are successful today, they work 3 Sigma. We're going to see what that really means. Those companies that work at 3 Sigma, they are generating or dedicating actually 50 to 85% of their effort, energy, money, and resources just to put out fires. This is a reality that happens. So we're going to see when that situation is presented at the end of the day, those organizations, more sooner than later, they will disappear. When we see into the supply chain, you see that there is a manufacturing organization. There is a manufacturing where things are transformed. Could be also, a service side where information is managed or sources to provide service. But at the end of the day, that organization requires sources, requires suppliers, requires raw material, information, input, and that is processed over here, and it has to be delivered. Sometimes in the normal manufacturing concept, you're going to see vehicles transporting those goods. Could be to a port, could be to an airport, could be to a railing station. And finally, that goes to institution, organization, or companies, and from there to the final all user. Edward Deming, who was a master on total quality management, he said once, if you can describe what you are doing as a process, you don't know what you are doing. So this is key over here. You need to know what are all the elements that take place when you are operating within certain settings in your operation, your business. It could be even an organization that is for not for profit. So it doesn't have to be something that generates revenue as such. Now, keep in mind, Mr. Deming, he came out from his career talking about the rule 85-15. What he meant from that is that 85% of the root cause of situations or defect, they came from the system, and just 50% from the employees or people. At the end of his career, over 60 years career, he analyzed his data and his information, and he concluded that maybe he was wrong. Instead of 85%, it was 96. 96% on his conclusion, the root cause of why we have defects, and call defect anything that goes away from the customer expectation, customer requirements. That, in essence, that is coming from the system. Now, who controls the system? Just company managers, organization owners, and management, they control the system. And just 4% is due to human error from the employees or bad intention, but just 4%. So that tells you if you work systemically, that was his approach, will be more prompt to get the desired result. So this is important as we walk through the Lean Six Sigma. Very good. So now keep that in mind that most of that comes from the system, but also let's think about where Lean Six Sigma came from. Let's stop now talking about Lean. What is the origin of Lean? People recall different activities that in essence that work like being looking for a lean process. But the one that really set a mark was Henry Ford back in Highland, Michigan in 1913, where by now officially we could tell that that was the initial step on lean manufacturing. So what Henry Ford did back then was transforming the way he was putting together, assembling vehicles. And he decided to create a railing system. And in that railing system, starting with a chassis, and then from there, everything started just happening. And that was the initial, that's how formally we can talk about Lean Six Sigma. I'm sorry, about Lean. And it could be Lean manufacturing, but it also could be about Lean transactional. Very good. So now, Six Sigma, where did Six Sigma come from? It came from Japan back in 1986 from Motorola. Motorola created Six Sigma, and back then, he called it the Motorola way. The CEO of Motorola, throughout the business, he said, well, we are doing very well. We are very successful. But here and there, I get a phone call. And those customers, they are not happy. And I want them to be happy all the time. So he put together in the beginning of in 1986, he put together a task force and tasked them to come out to see what was going on because he wanted his operation to be 100% effective. He was striving for excellence, and excellence means zero defect. So what that group found out that when you check things from percentage, let's say analyzing just 100 elements of something that is being analyzed, you just see few things. You don't see the whole spectrum. You don't see all that really is happening. When what they did, they went and came out with a million approach. So they said, okay, each opportunity, each customer request is an opportunity. So if we look into a million of opportunities, now we can see the detail. Now we can see the real thing. Now we can understand what's going on in our process. And for that, they came up with using Sigma that historically been used, especially by engineers, to denote standard deviation. So on analyzing a process where you have the variables are under control, you can see how the process behaves according to all different variables that interfere or that act within that process. And they realized that there were other elements, components, but that everything was on the system. So they create them the Six Sigma. Very good. In 2002, Michael George publishes his book, Lean Six Sigma. What Michael George came up with, and that was here in the United States, by the way, what he analyzes is like, hey, Lean is good, Six Sigma is good. Let's go ahead and place these two together and start the Lean Six Sigma. That was fantastic. Most companies today use the integrated approach, the Lean Six Sigma. Lean is looking for eliminating waste. What is waste for us on quality? When we talk about quality, Lean really, the waste really mean anything that does not add a value to our operation, to our process. So that could be to our process, could be to our customer, or something that is not regulatory driven. So it doesn't help my customers, it doesn't help my business, and it's not regulatory driven, that is just generating waste. And that's when you go to the supermarket and go to the meat section, especially the beef, and you're gonna see the packages over there on the ground beef that is a 63 or 64 lean, 66 lean, 62 lean. According to the level of lean, that means how much just meat is there without fatting. The fatting is the part that is considered the waste. So that's the concept in that regard. So let's talk very quickly now about lean principles. There are 5 lean principles. The first one is where you specify the value desired by your customer. On that, you gotta be careful. Why? Because sometimes as a customer, we want something. The question will be, what is that you want, that you can pay for, and you are willing to do so? Because sometimes I have the money, but I don't want to spend the money on that. So I can pay it, I can buy it, but I decide not to do so. So, but the 3 combination is like, I need it as a customer, I can pay for it, and I'm willing to do so. We need to understand that. It has to be very well defined, because that's what means value to our customers. That's the first principle. The second one is identify your value stream map. It's when you, within the boundaries of your operation, you understand that you receive already your raw material. You have all the components, like could be energy, could be pneumatic, could be oil, could be the wrapping. Anything that you will use and will be applied to the process, that is something that you really need. So that's all the way until the product or the service ends and is flushed out from your installation. That part over there is what you control directly. Upstream, you have within the supply chain, you have your suppliers. And the suppliers, they could come in different ways. One way will be bringing a raw material. Could be somebody that brings a service your equipment, calibrate your equipment. So the one that provide electricity, the water, all those elements that you need upstream on your supply chain, anything that is before your door on your operation. From your door out, that's downstream, that's your distribution channels. Sometimes you put it in the hands of a transporter, and that transporter will get it to a central location, and the central dispatch location will send it to in the retail business, it could send it to a store, and from that store, the end user might just get it. Sometime today, using Uber and Lyft and all these services, somebody will grab it over there and finally take it to the customer. But even that Uber driver, that Lyft driver over there, that individual is part of the whole supply chain. As you eliminate steps within that supply chain, the product cost should be lower, or your return as a business operation should be better, should be higher. So that's the simplicity when we talk about Lean Six Sigma. Next, we talk about that you gotta make sure your product flows smoothly, continuously. That is very important, because as you are gonna see on the different 8 elements of waste, or type of waste, you're going to see that one is like where you have to wait. When you're over there waiting for something, that's a waste. So you got to make sure your product, your service, your operation, your transaction doesn't stop. And your task will be typically to make sure you speed up that process, the cycle time. So it's the time that takes from the beginning to the end to flush out. You produce a product or a service. So that's important to make sure it flows continuously in all the stages. The other is that you incorporate over there the traction. We call that the pull system. So the question is, when do you want it? The answer is when I need it. That is when I want it. So if I ask for something and I write over there on the instruction, bring it on Sunday at 10 o'clock in the morning, and the supplier decides, well, I'm going to take it there on Saturday night. Guess what? Nobody will be there. Or if there is going to be somebody there, it's not authorized to receive it. So in your mind, you think that you're doing something good, but realistically, you are not, because you are going away from what is acceptable for the customer. So you need to communicate straight with your customer and say, is that okay if I take it there earlier? And the customer might say, excuse me, well, the same day, 15 to 30 minutes is okay, but please let me know. That is important. Now, what will be worse is that you come in to do it at 10 o'clock, and then here is 10:30, 11, and the product doesn't get there. Not just that, but sometimes, the service provider or the supplier doesn't even answer the phone. There is no way to communicate with that individual. So maybe your whole operation is over there on hold because whatever is needing is not there. Just take it to your office. Sometimes you are waiting for an email. If you ask somebody something, or somebody coming to send you an email by Friday, end of business. And Friday is there, no email. Saturday is there, no email. Sunday, no email. Monday, no email. Sometimes it passes a week, 2 weeks, 3 weeks, a month. Somebody's waiting for that information. So that's critical. That's very important for you to identify your external customers and also your internal customers and the stakeholders within your operation. Who needs something from me? So you need to speed up that process. Very good. Our last principle will be manage your operation towards excellence, perfection. What is excellence? Excellence is zero defect. Is that possible? No, but very close. When we talk about Six Sigma, it's when an operation generates just 3.4 defect or less in a million of opportunities. When you transfer that to productivity or in an operation, we are talking about 99.997. Just imagine, you move your comma, 6 spaces to the left. It's almost, very less than 1 in 100 opportunity. That's what we call zero defect. Let's talk now about the A type of waste. One of the waste that is transportation. If you ask somebody to go from point A to point B, once the vehicle or the mean, that could be an airplane, could be a boat, could be a railroad, once that train is there, and you say, oh, we forgot something, could you go back and bring that? They're waiting for you to go and pick it up. That going back and coming back, not just is a waste, because you are spending time, energy, fuel, everything, but you are holding somebody that is waiting for something. But also in risk management, you are increasing the level of exposure to be susceptible to face a risk. So, and as you know, you always hear about Murphy's Law. If that can happen, have the assurance that that will happen in my terms. Oh, by the way, my name is, you know, what's the name of the individual? It's Murphy's Law. That is going to happen. So you don't want that. Transportation of product, people, information, tools. You gotta make sure you make the process linear. So when you go over there, you be full, stuck. Sometimes you send the receiver, the distribution center, you send the packaging material, and you just pack that let's say that is a 53 foot trailer. You pack it with the product, you send it over there, and over there you set up an operation to do the packaging. So you can actually load more material. As you load more material, you are reducing your cost, because that is cost directly associated to fuel consumption. Especially in most nations today, that is a lot. Very good. The second one is inventory. In many countries, we believe that if I stock a warehouse with product, that is good, because I'm going to wait until the value goes up and then I come out and sell it. That's a very bad practice. You should not do that. You should just come up and just have what you need. That's what we call delivery just on time. Why? Let me explain a very typical operation within manufacturing. You decide that you need, let's say, acid, solvent, flammable materials. And because, you know, you just want to have it there when you need it, you request, you know, the amount that you need for a month. So now you have a big storage of chemical or hazardous materials. Now your insurance premium goes up, you need more space, and you're making your operation more susceptible to have a loss, because it might have a fire, an explosion, chemical plume or cloud exposure. So that's not good. So you need to negotiate with your supplier and get somebody local that ordered all the material for other people, and they just deliver yours right before your shift, right before your operation. That's the best approach. The next one, then, let me wait, my computer is slowing down. Very good. The second one is movement. Every time I turn, I have to reach, I have to bend, I get an awkward position. That is bad. There is a discipline, it's called ergonomics. Ergonomics is the one that is charged to study the relationship, the harmonic relationship between the individual and his or her working envelope. Everything I have to reach. There are positions that are neutral. On those neutral positions, not just I'm more productive for what I do, but I'm gonna minimize also stress. Stress in my eyes, my neck, could be my back. So I'm gonna minimize the probability to experience ergonomic disease. So I might get, for instance, carpal tunnel, because my workstation is not well set up. And there are things that I might just modify with my neutral position. We engineers, when we design typically for, 90% of the people and 5% are 95. 5% are too high or too low. So we design for that group over there of people. So that's a neutral position. If you see on the late of the 80s, you see that more cars start being designed mainly for women. And the reason is because normally the man was, working hard, but was a woman, or is still the woman, the woman that is taking the kid to school, taking the kid to the soccer, going shopping, going to the grocery store. So now they were having a word, hey, that's the kind of vehicle I want because I want to be happy. But not just that. At Volvo brought it very early in the last century, Volvo say, well, no, just started, gotta be safe. So start designing the vehicle differently, thinking about the wife or the mother and also on the kids. Very good. The next one is delay or wait. If you have to wait for something, if something doesn't come on time, could be material, information, service, instruction, that is another type of waste. The other is overproduction. If you should today produce according to planning, and planning is what we call a manufacturing forecast. So and we see the behavior, we see the historical data. The system today will tell you, according to the month, the week, and all that, or different events, that's what people should be asking you for. So you can, reach out those customers and say, hey, last year, by this month, you ordered this. You're planning to place a similar order. So with that, you negotiate all that. And then when you produce basically almost for your production. And with that, you don't generate excess of material, excess of product. In information, it is annoying when you get an email 10 times or even twice. It's annoying, at least for me. If I really the individual told me that, gave me the information, I don't want to be disturbed all the time giving emails, just telling me, oh, I told you this. Yeah, I got it. So I don't need to be informed again. The other one is excessive processing. One example will be, where they produce books. It used to be operation where the individual places a weight over the book. And they go there to force people to be over there pressing the book. And as we understand materials, that is what materials engineers do. We understand now that every single material has a memory. And that memory is the tendency that material has to go back to the original configuration. So if you press it over there, when you let it go, it's going to tend to go up again. So it doesn't have, at the end of the day, any value. And then when you put it in a box, it's compressed by itself anyway. So it's better just to let it go. So that over excessive processing is not good. So you gotta make sure to understand what are the variables that negatively or positively impact your process. So that is crucial when you are in the food business and you are frying something. You just have to fry by the time and the temperature and the dip or whatever the oil that is required to get the desired output. You don't want it less or more, because less it might be bloody. More is going to be now too hard, and it's not going to be satisfactory to the customer. The number 7 is the defective output. When David was doing his studies, he went and busy operation, and he was doing a bunch of observation. Which, by the way, if you have especially industrial engineers on the floor analyzing the process, make sure you have an effective communication with the workforce, because most of the time they believe that industrial engineers is there to see how he or she can eliminate that position, and the individual will lose the job. So keep that in mind when if you do that in your operation. But anyhow, then going over there and observe. Typically in the beginning with quality, we have the quality inspector at the end of the process. So there was somebody over there doing quality check. Oh no, this is not good, let's put it on the side. But that was the final product. So where that condition that made that product to be discoverable, to be not acceptable, where that took place within my process. It wasn't a step number 1, it wasn't a step number 2, 3, 4, and so forth. It was on 3, let's train the operator, the production operator or worker, to over there identify the situation and take an action. Even if it has to go out, it's gonna go out at that process, and you don't incorporate more cost to that product, and then for the end to be discarded. If over here we identify and we move it, that's the best. You are reducing the amount of waste that you are generating, and you almost eliminate the quality inspector at the end of the process. The last one, we talk about skills and abilities. It's happening a lot where you have a very highly qualified individual in your operation, but you are underutilizing that resource. Could be a person, could be a software, could be a machinery. The machinery have the potential to produce 1 million of parts or components in 8 hours, but you are using it 25% of the capacity. So you have an installed capacity and you are not utilizing it. What is happening? You're generating waste. So the same with individual. So today we talk more about team approach, working on teams dynamics. That is actually better because not just we come up with better solutions and ideas, and also those that participate in processes, in projects, we now own the process. So now nobody has to sell it to me. Now I have ownership. I have sense of ownership. I'm gonna defend it. So that is crucial over there. That is very important. But also we do a career, work. We learn. We increase our knowledge and our capabilities as individuals because we are learning from each other. That is fantastic. That is wonderful. Look at the geese when they are flying. They fly in an arrowhead formation. They understand that when they do that, the wind resistance is less. If somebody there to go out of that formation, immediately will realize that it's too hard to continue flying. So it goes back to the formation. When the first one gets tired, it goes back, and the immediate one will take that position. They are breaking the wind and they are reducing the resistance. They are being more effective. So it's good to go for the group, for the team interest. Now let's talk about Six Sigma. What is Six Sigma? I mentioned that Sigma is a Greek word that been for many years used as a symbol of standard deviation. Is those that know me know that I'm from Venezuela. I cannot make arepa, okay, with mango. It won't be arepa. You can make arepa out of wheat flour or corn flour. You can mix them and it still is arepa. But if you just get 10 mango and say, oh, let's make arepa, I'm sorry, but it won't be arepa. So same talking, you cannot get the dough of the arepa and place it in the microwave. At least with today's technology, you're not gonna get an arepa out of there. Or you can, if you boil that dough in whatever shape you do it, it's not arepa. We call it bollo. My dad used to boil first, let it cool off, and put it in the freezer, and then later just put it in the toaster and make an arepa. Well, that's a different way to do it. But not just because just boil it and put it out, oh, here are the arepas. No, that's not arepa. So that's important for us to understand that it will take from the raw material to what happened within the process that at the end we are going to get a desired product. Now, you have to specify what are the characteristics that will tell that you were successful and you reach your customer expectation. Okay? When we talk about 1 Sigma level, that means that our operation generates about 691, 452 defects per million of opportunities. Remember that the Motorola moved from percentage to 1 million of opportunities. So they analyze it in a wider spectrum. How does that translate to percentage, to efficiency? And that will be 30.8% efficiency. So you're just more likely you are not making it. You cannot get even the break even. So that is a very, very poor performance. That's 1 Sigma. when we refer to 2 sigma, that operation generates 308,539 defect per million of opportunity. That translates on efficiency to 69.1%. When you see the scale of value, that's a C. Well, it's not good. That C is not good. It still does a marginal performance. Most operations today run at 3 sigma. They generate 66,807 defects per million of opportunity. And the efficiency is 93.3. Hey, 93 is an A. It's a low A, but it's an A. So it's good. We're making money. In 6 sigma, we say if that operation does not reach excellence, 0 defect, that operation will disappear. Excuse me. Today you see, for instance, color disappear. It's part of the past. Couldn't make it. So that's our average performance. And yes, the operation is doing well, but it's not going to survive. Now, when we talk about 4 sigma, that is an operation that generates 6,210 defects per million of opportunity, and they're working even better. They're working 99.38% of efficiency. When you look into that, depending on what you're doing, if you are selling, burritos, it's not a big deal. But let's take it to, for instance, the mailing system in the US. That will translate to 5,000 incorrect operations a week. Imagine the check that just came recently due to the war situation with the pandemic. If you don't receive your check, you're going to be mad. You're going to be upset because you are not receiving your check. So imagine 5,000 incorrect operations a week. Multiply that by 53 weeks a year. So that's unacceptable. Let's take it now to the pharmacy operation that will account for 200,000 incorrect prescriptions a year. That's bad. Imagine if they give you something that wasn't for you. Paracelsus, in his conclusion, he said once, the difference between a medicine and a poison is the doses. You might have something good. Even in New Mexico, in Las Cruces, New Mexico, a grandma and a stepfather were sent to jail because they punished a little girl, not giving her food, but just water and water and water. What happened? The little girl lost all her electrolytes and had a heart failure, and the little girl died. So keep that in mind. The difference between a medicine and a poison is the doses. So 200,000 incorrect prescriptions a year are way too many. Let's take it to the civil aeronautic in the world. That's 2 daily landing or taking off failures. Could you imagine? Twice a day. When we analyze risk, we define risk as the hazard multiplied by probability. So as more time that you get in contact with the situation, you increase the probability that the hazard is going to materialize. So that is unacceptable. 5 sigma is an operation that generates 233 defects per million of operation. A million of opportunities. That in efficiency is good. It's 99.97. Wow, it's a high A. You are on the way to excellence, but that's the part that is so difficult to make it. Because you have been, linear your process, your system to a point that is too hard to make an improvement. That's why we said, for you to become 6 sigma, it will take you a very thorough 6 sigma deployment plan and a strategy, and it will take a good company like those that are on 3 sigma currently. It's going to take mainly from 5 to 7 years. For other operations, will take 7 to 10, 11 years. For some, they will never reach excellence. They will never become a 6 sigma. 6 sigma comes from the top. The top got to understand the need to, they have a need for that. And all of that is not just because you are having issues. We don't call those issues. We call those opportunities. So you have the opportunity to do better. When we analyze that, look into the Six Sigma. Remember the post office operation, the mailing system? Now in Six Sigma, we talk about 1.7 incorrect operation a week. 1.7 instead of 5,000. And on the pharmaceutical, you see just 68 incorrect prescriptions a year, no 200,000. And you see just one failure to land or take off every 5 years. That's when people say, oh, going a plane is too dangerous. Yeah, it's dangerous, but not necessarily it's risky. Yeah, you fall from there, more likely you're gonna die. You have a car accident, you might not die. But today we account more people dead due to a car accident than for airplanes. When you compare apples and pears for an hours of exposure, flying on an airplane is way safer than going on a vehicle. We are wrapping it up, this webinar. We very quickly just going to mention over there, we work everything on projects. Everything is a project. Could be a small project that you just do it, or it could be a comprehensive project that is a black belt project. And in project, we use something called DMA. And DMA, the D stands for define. Over there, you define the opportunity, you define the scope, the boundaries, and then you measure it. When you measure, it's very important, because if you don't measure it with anything, you cannot improve it. You don't know. You don't have a baseline. You don't have a reference element. And then you analyze. When you analyze, you look for the root cause. And in the I, you improve it. When you improve, you gotta be careful. You gotta contrast that from effort benefit, because sometimes the effort is too high and the benefit is too low. But the best is when the benefit is high and the effort is low. That's what we call low-hanging fruits. And the C stands for control. That's why we incorporate that to the system, write an SOP, or educate everybody and monitor that process. That's the main. When we work a project, besides the domain, we have the cycle. The cycle will identify the S for supplier, the I for input, the P for the process, the O for the output of product, and the C for consumer. Very good. The Lean Six Sigma, when Motorola create the Six Sigma, they say, okay, let's create a level of training. The level of training doesn't mean that you have to take the white, and then the yellow, and then the green, and then the black, and then the master. No. The only one that you have to take that has a prerequisite is the master. You cannot be a master if you are not previously a black belt. And they call it belt because they generate in Japan, and they say, let's use it as martial art. So they call it white, yellow, green, black, master. The white belt is just for general awareness. The yellow belt is the basic. The green belt is more for those individuals that are very, data driven. Those people that analyze data and stuff. They are the number savvy. That's not me, for instance. And the black is for those people that are just looking for the overall picture of managing Lean Six Sigma. We got to the end. We might have 5 minutes for Q&A. Let me see, we have any Q&A over there. So let me bring the screen back, so we can go ahead and let me see. There are no questions over here, so we are not going to have questions for now. So thank you very much for joining us today. That's the first of a series of free webinar. We were expected to have 15 to 30 minutes, but it has gone already to almost 50 minutes. That tells us something, and there are opportunities for us. Please go and send us in our website. You can go ahead over there and provide feedback. We need the feedback. And the people, the individuals that love us, give us constructive feedback. We want to know if I was effective in transmitting the information, the knowledge, if the tools were the appropriate one, if that's what you were expecting to receive. Okay, thank you very much. Please join us for other, oh, there is a question over here. I see a Q&A. Let me see. Well, Cinda was activated, but it's not actually visible. Let me ask, let me see. Yeah, I don't, somehow there is a question, but I cannot see it. I apologize because it doesn't show over here on my screen, but please write it. It's going to be recorded for us. We're going to go and check it, and we're going to provide the appropriate answer. Thank you very much for joining us. Please stay tuned. Go to our, this is going to be loaded to our YouTube channel. If you subscribe to our YouTube channel, you are going to be informed when another seminar is coming, or when we upload another seminar, another recording over there. It's not going to be just seminar, but also podcast and information that just pop up. You know, if we see that there is an important news that you gotta be aware of, we are going to go ahead and make sure you receive it. The same when you register in our website, we're going to have continuous communication with you all. Please help us to grow and to get every day better. Thank you very much.